welcome to this session. In this session, we are going to discuss the chapter 3 of NCERT class 11, trigonometric functions. The word trigonometry is derived from the Greek words trigon and metron, which means measuring the sides of a triangle. The subject was originally developed to solve geometric problems involving triangles. It was studied by sea captains for navigation, surveyor to map out the new lands, by engineers and others. Currently, trigonometry is used in many areas such as the science of seismology, which is the study of earthquakes and seismic waves, designing electric circuits, describing the state of an atom, architecture, predicting the heights of tides in the ocean, analyzing a musical tone, and many other areas. In our earlier classes, we have studied the trigonometric ratios of acute angles as the ratio of the sides of a right-angled triangle. We have also studied the trigonometric identities and applications of trigonometric ratios in solving the problems related to heights and distances. In this chapter, we will generalize the concept of trigonometric ratios to trigonometric functions and study their properties. An angle is a measure of rotation of a given ray about its initial point. The original ray is called the initial side and the final position of the ray after rotation is called the terminal side of the angle. The point of rotation is called the vertex. If the direction of rotation is anticlockwise, the angle is said to be positive, and if the direction of rotation is clockwise, then the angle is negative. The measure of an angle is the amount of rotation performed to get the terminal side from the initial side. There are several units for measuring angles. The definition of an angle suggests a unit, that is, one complete revolution. This is often convenient for large angles. For example, we can say that a rapidly spinning wheel is making an angle of 15 revolutions per second. We shall describe two other units of measurement of an angle which are most commonly used. They are degree measure and the radian measure. Degree measure. If a rotation from the initial side to the terminal side is 1/360th part of a revolution, the angle is said to have a measure of 1 degree. A degree is further divided into 60 minutes and a minute is divided into 60 seconds. Thus, 1/60th of a degree is called a minute and 1/60th of a minute is called a second. Hence, we have 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Since 1 degree is 1/360th part of a revolution, 1 complete revolution is equal to 360 degree, half the revolution is equal to 180 degree, and 3/4 of a revolution is 270 degree. Radian measure. An angle subtended at the center by an arc of length 1 unit in a circle of radius 1 unit is said to have a measure of 1 radian. We know that the circumference of the circle is 2 pi r, where r is the radius. If the radius is 1 unit, then the circumference of the circle is equal to 2 pi. Thus, 1 complete revolution is equal to 2 pi radians. In terms of degrees, 1 complete revolution is equal to 360 degrees. Hence, we have 360 degrees is equal to 2 pi radians. More generally, in a circle of radius r, an arc of length r subtends an angle whose measure is 1 radian. Consider a circle of radius r. Let AB be the arc of length L units. Let theta be the angle subtended by the arc AB to the center of this circle. Consider another arc AC of length R units. Then, by the definition of radian, we have the angle AOC is equal to 1 radian. We know that the ratio of the arc lengths is equal to the ratio of the angle subtended by these arcs to the center. So we have AB by AC is equal to angle AOB by angle AOC. Substituting, we get L by R is equal to theta by 1. Hence, we have theta is equal to L by R. Relation between a degree measure and a radian measure. We have pi radians is equal to 180 degree. Now suppose we are asked to find x degrees is how many radians? Then we simply cross multiply and find out the radian measure as pi into x divided by 180 degree. That is, radian measure is equal to pi by 180 into the given degree measure. Similarly, we have 180 degree is equal to pi radians. Y radians is how many degrees? We will cross multiply. So, degree measure is equal to 180 degree into y divided by pi. In other words, degree measure is equal to 180 degree divided by pi into the given radian measure. This is the relationship between the degree and the radian measure. Let us now convert 1 degree into radians. We have pi radians is equal to 180 degree. 1 degree is how many radians? To find out, we can simply cross multiply, or we can also use the relationship between the degree measure and radian measure that we just found out. That is, the radian measure is equal to pi by 180 into the degree measure. We get pi by 180 into 1. Substituting the value of pi as approximately equal to 22 by 7, we get the value of pi by 180 as 0.01746 radians. Now let us convert 1 radian into degrees. To do that, we know 180 degree is equal to pi radians. 1 radian is how many degrees? We simply cross multiply, or we can also use the relationship between radian measure and degree measure and do the calculations. We get 1 radian is equal to 180 divided by pi. Substituting the value of pi as approximately equal to 22 by 7, our answer will approximately be equal to 57.2727 degrees. We know that 1 degree is further divided into 60 minutes and 1 minute is further divided into 60 seconds. So, we convert the terms after the decimal point into minutes and seconds. So, we will now find out 0.2727 degrees is how many minutes. To do that, we can multiply 0.2727 into 60. We will get 16.362 minutes. Again, 0.362 minutes can be converted into seconds as follows. 1 minute is 60 seconds. 0.362 minutes is how many seconds? To do that, we can multiply 0.362 into 60. We will get 21.72 seconds. So, the answer here, 1 radian, will approximately be equal to 57 degrees, 16 minutes from here and 21 seconds. The 0.72 value after the decimal point here can be ignored. So we have 1 radian is equal to 57 degrees, 16 minutes, 21 seconds. Let us now convert a few degree measures into radian measures. Let us take 30 degrees. We know 180 degree is equal to pi radians. So 30 degree is how many radians? It will be 30 into pi divided by 180 degree. That will be nothing but pi by 6. So 30 degree is pi by 6 radians. We could also use the relationship between radian measure and degree measure and found out the answer. Now let us convert 25 degrees. We have 180 degree is pi radians. 25 degrees is how many radians? So we get 25 into pi divided by 180 degree. That will be, this is 5 5s are 25, 536 are 180. So we get the answer to be 5 pi by 36. Now let us convert 40 degree 20 minutes into radian measure. First, let us convert this 20 minutes into degrees. To do that, we know 1 degree is 60 minutes. So 20 minutes will be how many degrees? It will be 20 into 1 divided by 60, that is 1 by 3. So 40 degree 20 minutes is nothing but 41 by 3 degree. So this is nothing but 40 into 3, that is 120 plus 1, that is 121 divided by 3 degrees. Now let us convert this into radians. So we have 1 degree is equal to, 180 degree is equal to pi radians. 121 divided by 3 is how many radians? We simply cross multiply. Our answer will be 121 divided by 3 into pi divided by 180 degree, and that will be equal to 121 divided by 540 pi radians. Remember, when converting from degrees to radians, retain the answer in fractions and retain the term pi. These two things have to be kept in mind. Now let us convert a few radian measures into their degree measures. Let us consider pi by 6. Pi by 6 radians is how many degrees? To find out, we know pi radians is 180 degrees. So pi by 6 is how many degrees? To find out, we will cross multiply. We get pi by 6 into 180 divided by pi. So we get 30 as the answer. So we have pi by 6 radians is equal to 30 degrees. Next, let us convert 11 by 16 radians into degrees. We have pi radians is 180 degree. 11 by 16 is equal to how many degrees? To find out, we will cross multiply. We can also use the relationship between a radian measure and degree measure. So we have degree measure is equal to 180 by pi into radian measure. When we use the relationship also, we will get the same answer. Okay, so we have 11 by 16 into 180 divided by pi. Substituting the value of pi as 22 by 7, our answer will approximately be equal to 11 by 16 into 180 divided by 22 in here into 7. So calculating, our answer will be approximately equal to 39.375 degrees. Now, to convert 0.375 degrees into minutes, we will simply multiply 0.375 into 60. We get this from the relationship between 1 degree and minutes. 1 degree is equal to 60 minutes. So 0.375 degree is how many minutes? We will get 0.375 into 60, that is 22.5 minutes. Again, to convert this 0.5 minutes into seconds, we will use the relationship 1 minute is 60 seconds. So 0.5 minutes is how many seconds? And our answer will be 30 seconds. So our final answer here, 11 by 16 radians is approximately equal to 39 degrees, 22 minutes and 30 seconds. Next question. Let us now convert minus 4 radians into degrees. We have 180 degrees is equal to pi radians. Minus 4 radians is how many degrees? Or we can also use the relationship degree measure is equal to 180 divided by pi into the radian measure. And our answer will be minus 4 into 180 divided by pi. Substituting the value of pi as 22 by 7, our answer will be approximately equal to minus 4 into 180 divided by 22 into 7. And that is approximately equal to minus 229.0909 degrees. Now to convert 0.0909 degrees into minutes, we use 1 degree is 60 minutes. 0.0909 degrees is how much? So we multiply 0.0909 by 60 and we get the answer equal to 5.454 minutes. Now again, to convert 0.454 into seconds, we use the relationship 1 minute is equal to 60 seconds. 0.454 is equal to how many seconds? Or we simply multiply 0.454 into 60, that will convert the minutes into seconds, and we get the answer to be 27.24 seconds. So now our final answer will be approximately equal to minus 229 degrees. We have converted 0.0909 into minutes as 5 minutes and 0.454 as 27 seconds. We can ignore the 0.24 over here. Now, depending on the number of decimals you have taken after the decimal point, your answer may vary in minutes and seconds, and that is all right. Next question. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? Number of revolutions made by the wheel in 1 minute is 360. Therefore, number of revolutions made by the wheel in 1 second will be 360 by 60, that will be 6 revolutions. We know that 1 complete revolution makes an angle 2 pi radians. Therefore, 6 revolutions is how many radians? It will be 6 into 2 pi, that is 12 pi radians. Next question. Find the degree measure of an angle subtended at the center of the circle of radius 100 centimeters by an arc of length 22 centimeters. Given that r is equal to 100 and L is equal to 22 centimeters. Using the relationship theta is equal to L by r, we get theta is equal to 11 by 50 radians. Now, we will convert these radians into degree measure. We know that pi radians is equal to 180 degree. Therefore, 11 by 50 radians will be equal to 180 by pi into 11 by 50. And that is equal to 12.6 degrees. Now to convert 0.6 degrees into minutes, we use the relationship between a degree and a minute, and we get 0.6 degrees is equal to 36 minutes. Therefore, the degree measure is equal to 12 degree 36 minutes. Next question. In a circle of diameter 40 centimeter, the length of the chord is 20 centimeter. Find the length of the minor arc of the chord. Given that the diameter is 40 centimeters, radius will be half of the diameter, that is 20 centimeters. Also given, the length of the chord is 20 centimeters. So, we get the triangle AOB to be an equilateral triangle. And we know equilateral triangle have the interior angles equal to 60 degree. So, we get angle AOB, that is angle subtended by the arc AB to the center of the circle, is 60 degree. Converting it into radians, we get pi by 3 radians. Using the relationship theta is equal to L by r, we get L is equal to 20 into pi by 3. Therefore, the length of the minor arc is 20 pi by 3 centimeters. Next question. If in two circles, arcs of the same length subtend angles 60 degree and 75 degree at the center, find the ratio of their radii. Let us consider two circles, circle 1 and circle 2. Let R1 and R2 be the radii of circle 1 and circle 2 respectively. Let theta 1 be equal to 60 degree and theta 2 be equal to 75 degree as given in the figure. Angle formed by the arc of the first circle is 60 degree. Converting that into radians, we get pi by 3 radians. Similarly, angle formed by the second circle is 75 degree. Converting that into radians, we'll get 75 pi by 180. That's equal to 15 pi by 36 radians. Using the relation r is equal to L by theta, we have r1 is equal to L by theta 1 and r2 equal to L by theta 2. Now we are asked to find the ratio of their radii. So r1 by r2 will give us L by theta 1 by L by theta 2. Cancelling L, we get theta 2 by theta 1. Simplifying, we get 5 by 4, that's equal to 5:4. Therefore, the ratio of their radii r1 is to r2 is equal to 5:4. Next question. Find the angle in radian through which the pendulum swings if its length is 75 centimeter and the tip describes an arc of length. The first one 10 centimeters, second sub question 15 centimeters and third question 21 centimeters. So given that the pendulum swings, the length of the pendulum 75 centimeter becomes the radius of the circle. The arc lengths are given in the sub questions. So we have when L is equal to 10 centimeter, radius of the circle is 75 centimeter. Using the relation theta is equal to L by r, we'll get 2 by 15 radians. Similarly, for the second sub question, L is equal to 15, r is equal to 75. So using the relation theta is equal to L by r, we get theta is equal to 1 by 5 radians. Similarly, When L is equal to 21 centimeters, we get theta is equal to 7 by 25 radians. Next question. The minute hand of a watch is 1.5 centimeter long. How far does its tip move in 40 minutes? We know that 1 revolution is equal to 60 minutes of a watch. 40 minutes completes how many revolutions? That will be equal to 40 by 60, that is 2/3 of a revolution. We know 1 revolution is equal to 2 pi radians. 2/3 of a revolution is how many radians? To find out, we multiply 2 pi with 2 by 3, we get 4 pi by 3 radians. We have L is equal to r theta, substituting r is equal to 1.5 and theta is equal to 4 pi by 3 radians, we get 2 pi. Substituting pi value as approximately equal to 3.14, our answer is 6.28 centimeters. Therefore, the tip of the minute hand of the watch moves 6.28 centimeters in 40 minutes.